Hello everybody out there in YouTube land. This is Good Times for All, or Zachary Zabala here if you prefer. In this video we will be taking a look at the difference between coherent versus incoherent magnetism. We will again start with some quotes from Ken Wheeler.
Everything is electrical. The only thing that actually defines a
Bleep, bleep.
magnet is field coherency. Before this thing is magnetic attraction. That which we call magnetic attraction, is it something autonomous from gravity? No, it's not. The only thing that defines or differentiates out the two is field coherency. Something separate and autonomous. Well, here's gravity here, and here's electricity here, here's magnetism. No, all that shit is the same
Bleep, bleep.
crap! Like ice, water, and steam. They're not different things. Right now, by any definition of the term, and the force required to move this object, 50 pounds. Wow, that's over a piece of metal. You know, it still weighs 4 ounces if you put it over the dirt, or, wood. Yeah, do you know why? Because then we only have one object that has field coherence. I'm not able to induce induction. I'm not able to induce field coherency in a piece of wood or the dirt.
As you heard Ken Wheeler state, everything is electrical. Not only is it all electrical, but he adamantly shouts that magnetism, gravity, and electricity are all the same thing. The part we will focus this video on is the quote where he states the only difference between magnetism and gravity is field coherency. Instead of trying to tell you what he means, I will show you with a few demonstrations. First, we will take a look at two coherent objects and how they interact with each other. Here we have two cylinder magnets with the north poles of the magnets painted red. As you can see, when I try to place the red ends near each other, the other magnet tries to flip around to align with the non-painted end. This is because both objects are coherent, so the attraction and repulsion are both present. It pushes away when the poles are the same, and attracts when reversed. Now we will take a look at how multiple magnets, when not aligned, become incoherent. First, we will observe the magnetic field when the magnets are all lined up and coherent. As you can see, the more magnets we align pole to pole, the stronger the magnetic field gets. However, this is the complete opposite when the poles are not aligned. As you can see, the more magnets we add to our incoherent mass, the weaker the magnetic field gets. Now let's take a look at how a coherent object, the cylinder magnet, interacts with the large incoherent mass of magnets and ball bearings. As you can see, the red pole of the magnet is attracted to the mass, so we might assume that the bare pole of the magnet would repel. Yet this is not the case. As I flip the magnet over, the bare end is also attracted to the mass. So how does this relate to what we are calling gravity? Like gravity, incoherent magnetism is an attractive-only force. No matter which pole of the magnet is placed near it, the incoherent magnetic field is always attracted and never repelled. All matter is made up of charged particles, and like magnets, these particles have poles. The Earth and everything on it is ultimately a huge mass of charged particles. This is why everything is attracted towards the Earth. There are a few apparent exceptions to this rule, like helium, balloons, and rain clouds, and we will cover this in another video. In closing, the Earth attracts everything to it by virtue of its incoherent electromagnetic field And this is why we find a very weak bias between up and down, and ultimately what we call gravity.